Hello, this is Robert Guderian. Today we are talking about Comp 12 and specifically indexing and slicing. So how do we fetch the sum of the data? And for that we use slicing, and we will be using that for both assignment and for fetching data. We saw all of this last week with 1D arrays, so nothing new. We have seen that we can make data and slice it like this, where we can have a range, which we know it will give us a range of data from 0 up to and not including 10. And this will give us a slice starting at 1, going up to and not including 5, and stepping by 2. So that'll be the 1th element, which is the second one in, and then the 3rd element, and then up to and not including 5. So it'd just be 2 pieces of data. And of course we can try that, which is always convenient. We highlight it, jump it over to Spider. We can paste it in, and we do have to import numpy as np. Numpys. We're going to use the numpys today. There we go, 1 and 3. And there we go. That is what we want to see, and that is no surprise to us. It's icky syntax, but that's okay. But we have 2D arrays. So how do we get a column? Well, we can start using a comma to start talking about the different axes of our data. And that sounds very scary, but it's not that bad. When we jump over to our code, we have this data set from last time. So I'm just going to hit play so that it will be in my memory. And I can just play with data here. Nope, not data. It is called data, and then I got rid of it. Let's rename the other data to be called data 2. And we will actually do some printing of stuff today because it's pretty cool to really see it move. Great. So over here I can play with my data, and that's what it looks like. Now I want to get the second column, secondth. So that means index 1 in Rob speak. That is completely Rob speak, by the way. So what do we have? We have an iPad that's off. So I'm going to make myself some data. 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are all numpy arrays. These must be numpy arrays. This does not work with lists. This must be numpy arrays. I'm going to name this D because that's nice and short for us. And we know that these columns are indexed at 0, 1, 2. So when I say 1th, I mean this one because it's actually our second column. And when I say 2th, I mean column 2, which is, again, just because we index at 0 and our human brains interfere with our programmer brains. So I want just this column. Okay. Well, what do we see about this? Well, we're seeing that we're getting all rows. Okay. And just the second column, or column 2, just column 2. That's a question mark, not 2. 2. Okay. Well, let's jump back to our code. If I want all rows, what kind of slicing syntax would I need to use? Well, I can say A from the beginning, so I can just leave that blank using the shorthand, all the way to the end, leaving that blank. Okay. And then from that slice, which is all the rows, I just want the second column, or column 2. Oh, this is not named A. This is named data. And we have 6, 12, big number, and we scroll up a bit, we'll see that is indeed what we sliced. Oh, well, that was kind of neat. So we can think of the first slice as which rows we're getting back, and the second slice as which columns. So I indexed the second column. What if I want to skip the first row of this matrix? So I want to start at 12 and then go into 1804 and 20,000. Well, this can also be used as a slice, which is kind of neat. So let's go back to our problem statement over here. So I want to get just this data. Well, now it is no longer all rows. I will start a new drawing for you, so you can have that in your notes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Big one, and we want just these two. So we're going to have not all rows. We want rows 1 and onward. And we don't really know how many there are. We just want to skip the first row. And we still just want the second column. Okay. So what we can do in code is say, we still want column 2. That's true. But we want to skip the first row. So we're going to start at row 1 and then go up to the end. So we can leave that one blank because we know that that's magical. And then we got rid of the 6. This is all about drawing it first. Like, if you think I'm drawing this on my iPad for you, you are wrong. I'm doing it for me. Okay, what if I want to change this even one more time? Let's go over to the iPad. Now we want this slice. So it's rows 1 and beyond, and it's columns 1 and beyond. Well, that's each segment of my numpy slice can be a slice. So this is slicing my rows. This is slicing my columns. So I'm saying give me the columns 1 and beyond. This will return a 2D array for me. And you can see that this is the bottom corner here. Oh, did we get 10 and 12 in there? Oh, we did. Okay, good. I didn't see them that first time. Perfect. There you go. Think about slicing. Know what your data is, know what we want, and then you can slice it out by just slicing rows and columns. And we can even do the step thing in here too. Start, stop, step, everything is implemented in here. And we can index a single one, so slicing just one row. I can say give me the, press up. I could say just give me the first row by just saying 1. So I only want the first row and I want the columns starting at 1 and going to the end. That's fine too. So anything we could do in square brackets before, we can do again, but we have to separate them with a comma. Feels a little bit like a function. I think I maybe just ignored all of my slides. All right, yeah, given the array of any size, so we don't really know its size or don't care, and I'll even grab this, print out all the even columns. So I'm going to go over to my fancy dancy code here. We will use this plotting soon. So this will give me, if we read this out, I saw 2 rows, 3 columns, and it's going to count from 0 up to and not including 6 because I'm passing in the range 6. I could use np.arange there. I don't know why I'm not, but why not? Okay. And if I use M1 here now, it's in my memory. That is exactly what I got. 2 rows, 3 columns, counting up to not including 6. Great. Now I want all the even columns. So let's make this even bigger so we can really see how big this is. I'm going to do something cool for you. Row num, how many rows I have. I'm going to say I want 3 rows. I don't really care. Column num, I want something more like 10. I should even consider making these all caps because I'm using them as constants. I don't believe I'll be changing them. Now, what is my range here? I'm going to change this to np.arange because this is more functions than I need. And I can say, well, what's my maximum number? It's going to be row numbers times column numbers because that's how many spaces I have in here. And then I need to end the nd array function. And let's run this to make sure it works. M1, whole bunch of numbers. I don't really care what they are. I just know that I actually have a lot of columns now, and my even columns have odd numbers because we indexed by 0, and that ruins everything. So, you know why though? There's good justification. I'm gonna just call this evens because that seems to make sense to me. I want all rows. So I'm gonna just say full colon. I'll make that a little bit bigger for you. and comma, which columns do I want? Well, I want the even ones. So I just index it at 0, right? So I'm going to start at 1, go up to the end. I can leave that one blank, and I'm going to step 2. If it makes you feel a little bit better, you could put the length of one of your arrays in here. One of these arrays, like the actual rows. That might make you feel better, and I get that, but this will work too, and it's slightly more generic. And I'm going to print evens so I can actually see it. And there you go. There's your evens. And of course, this goes blitzing fast because that is just how numpy goes. Now, can we use inequalities? This is something you saw last week where we could slice saying where something is greater than something. Okay. Well, the answer is yes. So, but what would this do? This code doesn't work for us anymore. This would work for a single dimensional array, but it doesn't work for a multi-dimensional array because we can't say where an array is greater than 2. You have more than one piece of data. What does more than one piece of data greater than 2 mean? We also know that this will, inside inequality, is going to be returning a numpy array of booleans. And it has to be a one-dimensional numpy array of booleans. This syntax works on a 2D array. So I have a 2D array around. I haven't named M1, which is the same thing from the slides. M1 is greater than 2. Oh boy, that is nasty looking. You can see that we have 2 square brackets. And well, maybe I'll do it on evens. Evens is greater than 2. That's a little prettier. It's a 2D array. I can't slice if I pass it a 2D array. That doesn't work. So there's got to be a better way. So what we need is an NP array of booleans and a 1D NP array of booleans. So I believe I have a problem statement. We're going to build it up from 1 dimension so you can see that. And then we're going to put it up into 2 dimensions so you can see what that step looks like. So we're going to write a function that accepts a 1D array of integers and returns an array with just the even numbers. Okay. So I think I'm going to make a new file for this. I'm going to name it slicing because that seems about right. .py and enhance. Boom. So function. So this is def 1D evens, and I'm going to have my 1D, and then I want to get just the even numbers. I'm going to name it evens in here too, and I'm going to slice my 1 dimension where my 1-dimensional data is mod 2 is equal to 0. So if we divide by 2, get the remainder. That remainder is 0. It must be even. That is my slice. And then I can just return evens. So giving myself some data, I'm going to say 1D data is equal to np.arange, 0 up to 10. Doesn't really matter. And then I'm going to print 1D evens, passing it 1D data. And there's something grumpy. Invalid syntax. Oh, that went away. Okay, good. Boop. Evens. You can see any of that. Sorry. Scream at your screen like you're watching Dora the Explorer. So you can see that this is the magic where I have my slice, and that is what I'd want to see. How do we do it in more than 1 dimension? A write function accepts a 2D numpy array of ints and returns an array with the even numbers in the second column. Don't use a loop. No loops allowed. Okay. So what I would need to draw this for myself first. So what I want is I have some data, and I know that my 2D array has more than 2 columns, or 2 or more columns, because I'm using the second column. So that is column index 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You may recognize this data, and you know that these are all arrays in here. And we want to get the second column, which is column index 1. So the nice thing here is if I say my column index 1 is greater than, or sorry, mod 2 is equal to 0, well, that is going to give me true, false, true. So 2 divided by 2 is 1, mod remainder 0. 5 divided by 2 is 2, remainder 1, which would not equal 0. And 8 is even, whatever. But the important part is that can give me a 1D array. So let's program that. Here we go, programming. So I'm going to have def 2D evens. And I'm going to name it 2D. Again, these names are just for me. Your variable names cannot start with a number. That's why I spell out the word 2. And then I'm going to have evens is equal to 2D, where my, which column? Column index 1 is mod 2. So I want all rows. Oh, that's not true. I'm going to slice out rows where we don't have an even number. So I'm going to go back to my code because I just got that wrong. What are we returning? Well, we would be returning this and this. So that is not all rows. That means that we're slicing rows. Based on a column. Okay. So I'm going to be slicing rows where column 1 is not even. Or where I'll be slicing those out. Parlance is hard and it's very important. Okay, where 2D and I'm going to say all rows and then that index 1 column mod 2. So that'll give me that one whole column, which is the same length as the number of rows, which you kind of have to bend your brain a little bit to prove that's true. But we saw that was true on my iPad. 2 is equal to 0. And then return evens. So then we're going to jump down here and then print 2D evens. And we are going to pass in, I don't have 2D data yet, but I guess I will soon. I might just grab it from my demo over here. I have this one that I built with the ugly version, which is actually really interesting and really flexible, but really nasty looking. 2D data. And I need to get in my rows and column counts, which I'm going to copy in. So this one has a whole bunch of rows. Go. That's running off the screen a little bit. And I don't actually know what it looks like, so I'm just going to run this. I don't know what its second column. They're all odds, so that's a problem. If I change my column number to be an odd number, that will give me some variety, because math. 2 and 12. Oh, that's really interesting. Let's bring our row number up a bit because we want to see more rows. We're going to bring this down a bit to 3. And then it's kind of nice how that works. 2, 4. Okay, it's going to get all of those. And that'll work. Let's. Oh yeah, it's printing that. What's that? I know why they're all even. I'm not actually printing the right data. I'm going to print 2D data here. So I'm going to see the whole thing, and then I'm going to see the truncated version of it. Ooh, I need some visual space here. Again, I don't mind you seeing me hack a little bit because you can actually see my thoughts, which is interesting. Print 2D data. There we go. Yeah, it's just really long. So that's my 1D data. Here's my 2D data, which has a variety of odds and evens inside of this first column. And then we have the truncated version where we only have the even numbers in the second column. That's neat. You can the visual space actually breaks that out really nicely for us. So lots of rows, and we sliced out a whole bunch. And it was not a pretty line of code. One fault of numpy is that it's very hard to read, but it is very useful to have. So our next example, 2D location of endpoints. So the idea here is that we have a bunch of points, and each one of these points is represented by XY values. So this might be 1, 1. This might be 2, 4. This one might be about 5, 2. This one's 6, 4. And this one's going to be 7, 1-ish. Each one of these points has 2 pieces of data. So what we could do is store them inside a 2D array where you have 1, 1, 2 and 4, 5 and 2, 6 and 4, 7 and 1. Okay, that would actually make good sense for us. So each row is a point. And then if we wanted 3D points, what would we do? Add a third column, and that would be the z-axis. Neat. And matplotlib will actually print this out really nicely for us. So it actually makes for a very, very nice demo of how we can slice and show slicing all together in one. So you saw this command last time. I said that it's interesting. Now we're actually going to see it work, and it's kind of compelling. So we have 2 slices. The command here is these are all the X points. These are all the Y points. And then C means color and B means blue here. So it's going to draw a bunch of blue points. It's going to take this really long 2D matrix and then put it into this beautiful point. So let's get one more example here. I'm going to make a new file and enhance. And then I'm going to grab this import matplotlib. Do not memorize this. Actually, I guess you don't have to memorize anything. I have a very good lookup sheet. And we will get to here where we'll have data. And I'm going to make random points. np.random.randint. So the help here will say low points, high points, and then we can pass it a shape, just like we passed the ND array data shape. So I want to have 10 points and 2 columns. I'll make that a little bit, I'll kind of call this points. And if I run this, it's not going to do anything. Oh, well, there you go. There's my points. Randomly assorted. So if I keep on hitting play, they'll all go to different spots. I don't actually want that, so I'm going to say np.random.setSeed. I think it might just be seed 100. Oh, it is grumpy with me. Code. All right. Says code analysis bad, but this is doing exactly what I want, so that's awesome. So now it's always going to randomly choose the same points, which again sounds bizarre, but is actually very useful. Now I want to do math on my entire matrix. So what I want to do first is not use slicing at all, but I'm going to grab this and I'm going to make a bunch of green points where my data is now equal to data plus 1. So it's going to move all my points, both X and Y values, up by 1. It's going to add 1 to my entire matrix. So I want to see that happen. So data plus 1 changes 9s up to 10s, and let's look at this last row. 59 up to 60, 17 up to 18. If I run this, I'll see this kind of shift happen, where you can see that my points have blue, and then there's a green just to the top of it. I unfortunately can't make this bigger for you, but I can even pull it out a little bit more by saying +3, and there's this kind of shadow effect. Cool. What if I only want to add to my X dimension? Oh, okay. We'll talk about log transform in a bit. It's too fancy. Well, let's do X dimension, and then we'll do the sum. So my X dimension can be sliced and moved. So this is exactly what we saw last time. where we can say data. Let's not do it. Let's do it right here. Data, and I want to have this happen to all my rows, colon, and just to the column. To which column? Column 1. Okay, I'm going to use that same slice and say all of that data plus 1, or maybe I'll say plus 2 to pull it off. So now instead of going up and right, it'll only move it to the right because that, oh, sorry, just up. Y is up. So then we'll have a shadow pointing up. So we can assign to a slice provided that the incoming data is the same shape. And that shape thing is important. So this is the exact same length. This is the entire column plus 2, and I'm going to reassign my column and my data to that new updated data. I could use the shorthand if I wanted to. There's nothing wrong with that, other than you know that I spent 6 hours of my life debugging that once, and that will apparently work very differently. This is exactly the bug that caused me 2 hours of grief. Plus equals 2, not equals plus 2. Hey, there we go. Yeah, think you'd learn. That's why you don't use that one. Use slicing to get rows where the sum of values is greater than 10. Oh, so now we actually have to do math. We hate math. No, that's not true. I think most of us like math. So the sum of columns, well, what do I have? I have column 0 and column 1. And then each one of these will have a result. Okay. And I will be slicing on what? Rows or columns? Well, I want to get rid of rows where the sum of these 2 points is less than 10 or greater than 10. Doesn't really matter. So I'm going to shift these one more time. I can do them in a different color. I forgot what other colors exist. So we're going to have my data. And I'm going to call this filtered. I'm going to switch over to my code. Is equal to data, and I'm slicing out rows where something is true. So this is on my rows slice, where data, all rows, and the first column, 0th column, plus data, all rows, and the 1th column is greater than 10. Out of my slide, I said greater than 10. And then I'm just going to print out filtered. Diltered. Let's copy and paste. You don't have to spell it right. You do have to spell it consistently. Sorry. Let's talk about Python 2 syntax. Python 2 did not require you to have brackets here. And I'm an old enough dog that I get busted by that once in a while. Woo! I made a mistake. Interesting. Operands could not be broadcasted to other shapes 10 and shapes 1, 2. Ah, spot the bug. The 1th column. I need that all rows, comma, first column. That is very hard to debug unless you've seen it 15 times. There we go. I'm trying to think if we scroll up. Let's print out data first. We haven't modified data, so we can say print data, and then we can say print nothing. So we'd give us some visual space, and that will give us 2 different columns, and they are all greater than 10 by the looks of it. So that's funny. So we can change this for our own needs, and we're going to say greater than 20, just so we can make sure that this slice is working. And or maybe greater than 27 plus 9. That's 36. Let's say greater than 36 to see that one go away. Bye. It's gone. So we can do math. Remember, everything in NumPy returns a NumPy array. This slice is returning a NumPy array of just the X values. This slice is returning a NumPy array of just the Y values. Those two get added together and returns a NumPy array of the same length of the number of rows. And we're saying all of that greater than 36, which all of this is going to return a NumPy array of Booleans that will slice this. That is a lot of steps in one line of code. We could break this up some to see how that happens, and I encourage you to try that. But that is what we can do, which is pretty amazing. So selecting data isn't too hard, but you have to draw it out first. Think, then program. There's a carpenter saying where you measure twice, cut once. Here, write it down 4 times and then program it once. You'll save yourself a lot of time, I guarantee you. Have a good day.